Meet Jack, a passionate seller with an incredible product to share with the world. But there's one challenge he faces: finding the perfect price for his masterpiece. You see, Jack knows that pricing is crucial. Set it too high, and he risks scaring away potential customers. Set it too low, and he might not cover his costs. It's a real dilemma, but just when it seemed like the odds were against him, Jack discovers the ultimate secret weapon in his quest for the perfect price: customer prediction service. Our revolutionary website uses advanced machine learning algorithms to predict the most appropriate price for his product based on its category. With a few simple inputs, like the product's features and target audience, Product Predictor Pro works its magic, analyzing vast amounts of data in a heartbeat. No more guesswork, no more doubts. Product Predictor Pro empowers sellers like Jack to make informed decisions, maximizing their sales potential and making their product stand out in the crowd.
All right. Can you hear me?
Yes.
All right. Let's start with a demo of our project. In this configuration, we're going to give details about the purchase, quantity of items, price, month, year, location of purchase, and our model is going to tell us what category that product belonged to. So we can just put in some values here. Let's say 3/30, and the month, maybe February, year 2012. Let's have a female buyer, paid with credit, and let's do the Mall of Istanbul young adult. So as you can see, our prediction here, all right, we will leave the page is taking some time to load. Give that a second. Right. We'll just run that through again real quick. There we go. So as you can see, the best category based on those values I just put in would be the so, and this will change depending on the values we put in, obviously. So let's say we only buy one product, make it really expensive. We buy it in March 2018 this time. Let's have a male buyer and see what happens. So now for those values, the best place to shop is in technology. So now you've seen the demo of our project. Now you'll get to see how our back-end adventures went.
All right, so basically how we started this off, we first got our data set from Kaggle, and after that, we just used pandas to read it. After that, we started using Plotly and other stuff to get our graphs. So in our EDA here, in exploration, although right now what you see hasn't loaded in yet, but it's definitely there. Just give it a second, I guess. But for now, I guess I'll just say that our first graph is going to be a pie chart. Oh, there it is. It's a pie chart. It's going to be comparing price and category. As you can see, all the key on the right tells you what type of categories there are. And on the pie chart itself, it just tells you how it's distributed. So from what I see here, and from what you guys can see right now, clothing is, spent on the most, and it's probably purchased the most. So there's that. The next one is going to be a sunburst graph. So if you can scroll down. Here, we're comparing a bit more things here. We're going to be comparing the categories, the payment methods, as well as the gender. Again, in the center here, clothing is what people buy the most, and people use credit cards and cash more than debit cards. So those are like the top two. And then if you were to look at the male and female buyers, you can see that female is generally more than the males. So next one is going to be the 3D scatter plot. So this one is comparing category, quantity, price, and shopping mall, so a lot more. As you can see that the graph is kind of hard to read, probably because our data set is like 99,000 things, like points. So like, yeah, it's kind of hard to read, but the colors, the price, you could probably like tell things apart a bit better. From here, you can see that technology, well, probably from here you can't, but if you were on the website, you'd probably be able to see that technology. It increases in price proportionally to its quantity, as you can see with the colors as well. The most expensive here is in yellow, and etc. So next one is going to be the sunburst, another sunburst. I love my sunburst. This one is pretty simple. In the middle, again, it's just category. Outside is just the age groups. We kind of split the age groups. So basically the ages, they were given in numbers in our data set, but we were able to like break it into different like age groups. So it's basically students, senior, young adults, and middle-aged. From what you can see here, young adults and middle-aged people are the primary buyers, I suppose you could say that. And next is going to be the histogram. It just compares the shopping malls, quantity, and age category. Here, Canyon Mall and the Mall at Istanbul is the most popular places to buy things. And again, these colors represent the age groups. Last time I checked, middle-aged and young adults are still the primary buyers. So it basically supports the idea in the previous sunburst. And that's about it for the EDA.
Now we go take a look at the models that we used to train and predict our data set. We'll go over the random forest, which we used for our forum. Now, random forest works by creating multiple trees, and each of these trees tries to make a prediction on the information it's been given. Now, if you just take the result of one of the trees, you get a very inaccurate answer or prediction. But if you take predictions, take the vote by the majority, which all agree on a single prediction, you get a very accurate result. And if you scroll down, you notice that we got 100% accuracy on this model. Normally, this would be an issue because this would mean the model most likely overfitted. But because we were tuning, and it took around 2 hours for this to complete tuning, we are very confident that the accuracy of this model is genuine and the 100% is legit and we can trust it. Now the next model, is decision tree. We go drop down. Now the decision tree works by creating different nodes which decide, hey, based on these results, what is it? And it keeps going down the list in each depth until it gets to a final result where there's no more nodes to go down, and it's just a bunch of leaf nodes, which are all terminal nodes. And after that, it compiles them, does a little voting, and based off that, it makes a prediction of the voting. Now, if you scroll down, this was our worst model. That's only because before the tuning, it had a 100% accuracy. But unlike random forest, we knew this was an overfitting issue, and that the model just tries to overfit with the data set it would be given on test. But after tuning the model, we got a very accurate, less accurate result, but it's a more realistic result that you most likely actually see in the real world. Now for our last one is K nearest neighbor. Now the K and K nearest neighbor is just a little variable that's just lets us change the size of the area that a point searches for its nearest neighbor by a factor of K. Now, what it tries to do is in this area called K, it tries to group itself by how many neighbors in a class is beside it or nearest to it. And depending on who's near to it, it will categorize itself in class A, B, or whatever you're trying to categorize in. Now for the accuracy we got a very good accuracy, both before we tuned it and after we tuned it. But we trust the accuracy after we tuned because, as we know, it's less likely to be overfitted before tuning. Now, even though it is our last model I'm showing off, it's definitely not the worst one, and I'd highly recommend it if you ever want to use it for data science.
Okay, so now we've shown you our 3 models, and we mentioned tuning. So how does tuning work? Basically, our models, we can put different parameters. Think of them as settings, which change how the models predict things. They can predict things more accurately or less accurately depending on which settings or parameters you use. So the process of tuning is where we find the very best parameters or settings that help us find the most accurate result. The way we did this was using a tool called Grid Search CV. And what we did for each model, we compiled all the possible different settings that we could use, and we had Grid Search iterate through all of these settings, and basically it ran the model, did like a huge amount of predictions, and every prediction used a unique combination of settings. And the prediction with the best accuracy we knew had the best settings. So that's how our tuning process worked.
Hey, it's Eddie. I'm going to be talking to you about the parametrics and how we evaluated which algorithm was the best fit for our data. So the most commonly known one is, of course, accuracy. How you calculate it is you just do total of successes over total outcomes. And so what actually tells us is just how many, what we can expect from our machine learning model and how many we can correctly predict out of total number of times we run it. And so although accuracy is important, it fails to describe errors that our machine learning model has in our data. So let's just say you get 100% on a math multiple choice test. That doesn't necessarily mean you're going to get that same 100% for the next to come. And so that's why we have precision. But it's not the same precision that you might be used to. How you calculate this type of precision, it's you do true positives over true positives plus false positives. And so what this is known as is the positive predictive value, and it is mainly used when we need to predict the positive class. More specifically in situations where the cost of false positives is significantly greater. And so this metric is especially useful to measure the success of prediction when the classes are really imbalanced. Yeah.
All right, and then the next two parametrics, we have recall value and F1 score. So for recall value, our equation is true positives divided by true positives plus false negatives. And basically this parametric measures how good our machine learning model is at identifying actual positives out of all the positives that exist within our data set. And it represents a true positive rate. So this means that the higher the value is, the better our model is at identifying both positive and negative values. And then for the F1 score, so the equation for this is 2 times precision times recall over precision plus recall. So the F1 score is a key metric used for evaluating binary classification models, and it balances precision and recall to provide a comprehensive assessment of accuracy and effectiveness, especially in balancing class distributions.
So before we get to our conclusion, I'd like to talk about some of the problems that we had to tackle during this. So we had a really big data set with around 99,000 values. And so when we placed it in a scatter plot, it almost filled out every single slot. So it made it very, very difficult to detect any patterns or any predictive characteristics. And so we had to overcome this by really catering our data set to very specific types of graphs. And another problem we had was choosing classification model. As you saw before, a lot of our accuracies and values are really, really close together. So it's really tough to see which of those models would be the best fit for our data.
Yeah, and then another problem that we had was, so when we were training our models, all of our categories were strings. And then, so what we did was we changed those strings into binary numbers and arrays so that the computer can read them and actually use them for training our model. And then when we were tuning our models as well, like given that we have a huge data set and that we have multiple values, it took a very long time to train our models, especially the random forest one, which again took about 2 hours, I'd say. And then the other ones took a couple of minutes, but yeah, it was worth it in the end though, so.
Okay, so in conclusion, of the 3 models, RFC was our best, producing 100% accuracy, as Leon described before. Nevertheless, our models, KNN and DTC, were not bad by any means. KNN produced a 99.9% accuracy, and DTC produced 95.7%. There's a chart showing the performance of the 3 models here, and RFC is clearly superior. So what does this mean for our project? With this model, customers can figure out what category they can shop in by inputting their price, payment type, shopping mall, and so on. Additionally, businesses can use the model to choose price points for their products and what time of year to sell certain items. So from this point, our team is looking to improve the usability and effectiveness of our prediction model. So this is the team. David was our project manager. I and Eddie were the machine learning engineers. Mikita and Leon were our data scientists. Peter was the web designer, and Chetan was our coded instructor, of course. So thank you for listening. We are the humble hedgehogs.